In the preceding sections, we have analyzed the technical foothold of our solution. This section describes how to use Huawei Cloud to implement our solution. Huawei Cloud provides online cloud services for customers. These services are developed based on Huawei's 30 years of technical accumulation and experience. They are stable, reliable, secure, and sustainable. As the foundation, Huawei Cloud provides a powerful computing platform and a more easy-to-use development platform for Huawei's full-stack all-scenario AI strategy. For IoT development, we use the Huawei Cloud IoT platform to collect and report the data generated by the development board to the cloud. The IoT platform provides a rule engine to forward data to other Huawei Cloud services for subsequent data processing and analysis. In addition, the IoT platform allows upper-layer applications to call APIs to remotely control devices. In this way, we can adjust the price, location, and status of vending machines in real time based on the dynamic product data, implementing intelligent O&M management. For AI development, Huawei Cloud provides model arts to pre-process reams of data, semi-automatic labeling, large-scale distributed training, automatic model generation, and on-demand deployment of device edge cloud models are available, helping users quickly create and deploy models and manage full-cycle AI workflows. One-stop means that all phases of AI development, including data pre-processing, algorithm development, model training, and model deployment, can be completed on Model Arts. Model Arts supports mainstream open-source AI development frameworks such as TensorFlow and PyTorch, and provides high-performance CPUs such as V1004 for accelerating model training. Model Arts aims to make AI development simpler and more convenient. In this experiment, we use Huawei Cloud Model Arts to predict and analyze product data and optimize the vending machine placement. In this experiment, servers in the Java environment are required to support data analysis. Therefore, Huawei Cloud ECS is used as the running environment of the jar package. An ECS is a basic computing component that consists of CPUs, memory, OS, and elastic volume service EVs. After buying an ECS, you can use it on the cloud just like you would use your local PC or physical server. ECS supports self-service purchase. You only need to specify the specifications such as CPU and memory and login authentication mode. You can also modify ECS specifications as required to build an efficient, reliable, and secure computing environment. The real-time data of the development board and jar package needs to be collected and dumped. Therefore, we use Huawei Cloud DISE to achieve this. DISE addresses the challenge of transmitting data outside cloud services to cloud services. DISE builds data intake streams for custom applications capable of processing or analyzing streaming data. DISE continuously captures, transmits, and stores terabytes of data from hundreds of thousands of data sources every hour, such as IoT data collection, logs, location tracking events, website clickstreams, and social media. After the vending machine is connected to the cloud, data needs to be stored. In this experiment, we use Huawei Cloud OBS to store data. OBS is an object-based storage service. It provides secure, highly reliable, and low-cost storage service for a large volume of data. OBS provides users with unlimited storage capacity, stores files in any format, and caters to the needs of common users, websites, enterprises, and developers. Neither the entire OBS system nor any single bucket has limitations on storage capacity or the number of objects files that can be stored. You can access and manage data stored in OBS through the OBS Management Console or various OBS tools. With OBS provided SDKs and APIs, You can easily manage data stored in OBS and develop upper layer service applications. Based on the preceding Huawei Cloud services, we built an E2E AIoT vending machine solution, including IoT platform development and AI prediction and analysis. The development of the IoT platform focuses on the product selection function of the vending machine. Here, we use the BearPi development board to simulate the vending machine transaction system. You can perform simple operations to purchase products or add multiple products to the shopping cart. However, a single development board cannot generate enough data for subsequent data analysis. Therefore, a jar package that can generate a large volume of transaction data is used to simulate real-time data reporting. The data reported by the development board is uploaded to DICE through the Huawei Cloud IoT platform. Data generated by the jar package is collected and transferred in real time by DICE. After the transfer, the data is dumped to OBS according to the pre-configured dumping task. Such data will be used for model training and development on Huawei Cloud Model Arts. In this experiment, we analyze and predict the sales based on the previous sales data. Perform clustering analysis on the sales data to find the optimal placement for the vending machine, and apply the model to the experiment data to verify and optimize the model, finally increasing the revenue for the company.